Friends, welcome to Engineering Mathematics 2. I think yesterday we have discussed about preliminaries of a differential equation. Suppose if I want to define a differential equation, what are the preliminary things we required? I think I have given yesterday, and I have also given what are the learning outcomes of differential equations, and along with that I have mentioned some textbooks about a differential equation. One is Advanced Engineering Mathematics by Zill and Wright. Along with this textbooks, I have also mentioned some other textbooks, Grewal and few more textbooks. We can refer those textbooks for the study of a linear differential equation with constant coefficients. And we have also discussed about why we want to study a differential equation and what is the concept of a differential equation, and how we are going to recognize an ordinary differential equation, and how we are going to calculate order of the differential equation, similarly degree of the differential equation, and what are the objectives of second order linear differential equation with constant coefficients, right? And how do we call a particular equation is an general solution. I think yesterday I have considered one or two examples, and I have assumed a solution of the given equation. Then I have proved that two functions y is equal to, or y1 is equal to 1 and y2 is equal to, are the solution of the particular differential equation. And after that we have called it as an linear combination of two independent solutions. Later we have defined a general solution. Along with this, I think yesterday we have discussed about what are the characteristics of the solution, right? So as I have mentioned, we may obtain or we may get a solution of an algebraic equation, right? So what is the solution of an algebraic equation? So we will expect two numbers or more than two numbers depending upon the given equation. Exactly in the similar way, suppose if we have an differential equation, if we solve the differential equation, so we will obtain a function or more than one function. Friends, I think I have given all these informations in the last session, right? So in this session I have planned to solve one or two initial value problems, right? So before solving an initial value problem, now first I have to define an initial value problem along with the physical meaning of the initial value problem, or what we call it as an interpretation of initial value problem. So once we are able to define first order initial value problem as well as a second order initial value problem, then we will try to find out the solution of the first and second order initial value problem, right? And after obtaining the solution of initial value problem, I have planned to draw a graph of a solution curve of the first order as well as a second order initial value problem, right? So how we are going to draw the graph of a solution curve? Friends, here I am going to introduce a new software called it as GeoGebra, right? So it is the combination of geometry and algebra. It is a very simple software, right? It can be downloaded from the internet. It is an open source, right? So official website is www.geogebra.org, right? So from this website anybody can download freely. So I am going to demonstrate how we are going to draw the graph of a solution curve, either by using a smartphone or by using PC or laptop or tab. And after that, I have planned to solve a second order linear differential equation, right. So, how we are going to solve a second order linear differential equation with constant coefficients? Again, that depends upon auxiliary equation, right. Again, auxiliary equation can be solved. You will get a nature of roots. Depending upon the nature of roots, we are going to write down the solution of the given differential equation, right. Sometimes you may get real and equal roots, real and unequal roots, and complex roots, right. So, what I have planned to cover in this session, right. So, I want to begin with an first order initial value problem, right, or what we have said in the last semester, first order a linear differential equation, right, dy by dx plus py is equal to q. So, this is the general first order linear equation we have studied in the last semester, right. What is the solution of this equation? We are already familiar with this equation. Solution of this equation can be written down in this form: y into integrating factor is equal to integration of q into integrating factor with respect to x plus c. So, this is the solution of the first order linear differential equation, right. So, exactly in the similar way, now we want to solve higher order, second and higher order linear differential equation with constant coefficients. Here we know that p and q are functions of x, right, where integrating factor is equal to e to the power integration of p dx. It means here p is known, q is known, right. So, using the value of p and q, we can evaluate integrating factor, then you will substitute in the solution, and after that we can integrate q into integrating factor. I hope like this we will find out the solution of first order linear differential equation, right. So, as I have mentioned, now we want to define a first order initial value problem, right. It is of the form dy by dx is equal to a function of x and y, right. Now, yesterday we have defined a differential equation may contain function of x and y and its derivative, right. So, here initial value problem can be defined in this form: dy by dx is equal to function of x y subject to y of x naught is equal to y naught. So, it means here they have given one condition, right. So, it is easy to interpret in geometric terms. It means what is the meaning of this equation, right. For one, we are seeking a solution of the differential equation on an interval I containing x naught, so that solution curve passes through the prescribed point x naught and y naught. So, it means that so friends, we are able to find out the solution of this equation, right. Solution curve passes through this point, namely x naught and y naught. So, that is the meaning of the first order initial value problem, right. Now, exactly in the similar way, now we are able to define second order initial value problem is of the form d square y upon dx square is equal to function of x, y and y single prime subject to y of x naught is equal to y 1, right. So, we want to find a solution of the differential equation whose graph not only passes through the x naught and y naught, but passes through so that the slope of the curve at this point is y 1. So, it means when you draw the solution curve, right, solution curve passes through the point x naught and y naught. At that point, suppose if we calculate, right, what is the slope of that point, right, slope of that point is y 1, that is the meaning, right. The term initial condition derives from physical system. So, it means how we are going to define an initial conditions, right. So, we can define initial conditions from any physical system, where the independent variable is t, right, where y of t naught is equal to y naught and y prime t naught is equal to y 1 represent respectively the position and velocity of an object at some beginning or initial time t naught. So, it means, so here what is the initial position of an moving object, that may represent t naught and y naught, that's clear, and what is the velocity of the object will represent another condition. So, it means that is the meaning of the second order initial value problem, right. Now, here we can consider one simple initial value problem, namely y single prime is equal to y of 0 is equal to 3, right. So, they have given first order differential equation, because highest derivative is dy by dx, right. I have mentioned a differential equation can be denoted by using different symbols. Here instead of writing dy by dx, we can write y single prime, right, and they have given one condition y of 0 is equal to 3, right. How do we find out the solution of this differential equation, right. So, we are already familiar with many methods we have studied in the, or we have discussed in the last semester, right. Here I am going to use one known method, namely variables or separable, right. So, this equation can be written as dy by dx is equal to y, or it can be written as dy by y is equal to dx. It means variables are separable. Directly we can integrate. On integration we can obtain y is equal to some constant c into e to the power x is the solution of the equation, right. So, using y of 0 is equal to 3, we obtain the value of c, right. So, solution of the particular solution of the equation is y is equal to 3 into e to the power x, right. I hope friends, all of you are observing this graph, right. So, as I have mentioned, c into e to the power x, it means when you draw the graph, I hope you will get a red curve, it is a particular graph, right. So, you can animate the same graph, right. So, how we are going to animate? So, you can give some values to c, is it clear, right. Now, as friends, as I have mentioned, so when you download the software called GeoGebra, you can see an icon like this, right. So, this icon represents a software GeoGebra, is it clear, right. Friends, this software containing two windows, right. So, what we are observing, this window is called a graphic window, right, and I will show one more window. This window is called an algebraic window. You can see the algebraic equation and as well as you can see the graph, right. Now, here I can type, it is an input mode, right. In this I can type any function, right. Now, what we have observed here, I have obtained the solution of a differential equation. What is the solution of a differential equation? C into e to the power x. So, it means I have to type exponential function, right. So, I will type an exponential function, right. So, e x p of x, okay. Friends, I have typed exp of x, it means exponential x, right. So, I hope now you can see the graph of exponential function. Friends, here I can use some more commands or options if you are interested you can use afterwards, right. Suppose if I want to change the color of the graph, I can change the color of the graph, right. I hope now you can observe a different color exponential function, right. So, if I want to make an animation, it is also possible to make it as an animation, then I will include an arbitrary constant, say c, right. I will type it as c into e x p of x. Okay. I hope now you are observing animated curve, right. So, one curve is moving, I think blue color curve is moving, right. So, it means it is taking values of an arbitrary constant between the -5 to +5. You may ask why you want to take values in between -5 and +5, not necessarily, right. So, we know that c is an arbitrary constant, right. So, if you want to take 1 to 5, you can take 1 to 5, according to that we can obtain the solution curve, right. Or if you want to take -5 to 5 or -10 to +10, so like that we can change the values for c, according to that you will get the curve, right. So, friends, what I wanted to say that now first you try to learn how do we draw the graph of an solution curve, then we are able to interpret, right. So, what it indicates, why it is moving upward direction or downward direction. Okay. Now, exactly in the similar way we shall solve one more example, right. Solve the initial value problem. Is it clear? Y double prime minus y is equal to 0, y of 0 is equal to 4, y dash of 0 is equal to -2, right. Solution of this equation. Friends, you observe the given equation is an differential equation. It is containing y double prime. It means it is of the type d square y upon dx square. It means highest derivative is d square y upon dx square or y double prime. It means the order of this differential equation is 2 and the degree of this differential equation is 1, and they have given two initial condition, y of 0 is equal to 4 and y prime of 0 is equal to -2, right. So, first we can find out symbolic form of this equation, right. So, this can be written in this form, d square minus 1 is equal to 0, right. Suppose if you replace d by m, you will get an auxiliary equation, namely m square minus 1 is equal to 0, then you will get roots for the auxiliary equation. I can write down m is equal to 1 and m is equal to -1, right. So, it means you will get two different roots, 1 and -1, right. So, then how we are going to write down the solution? Now, yesterday I have explained superposition principle, right. Suppose if we get two independent solutions and we can combine those two solutions and you may get equation like this, and that equation also satisfies the given differential equation, then we may call it as an solution of the given equation, given differential equation, right, or general solution. So, it means using the superposition principle, I can write down y is equal to, or y of x is equal to c1 e to the power x plus c2 e to the power minus x. Is it clear, right? So, this is the solution, right, and along with the differential equation they have given conditions, right. So, now I want to use these conditions, right. Suppose if I want to use first condition using y of 0 is equal to 4, we obtain, it means I am going to replace, it is of the type y of x naught is equal to y naught. What is the value of x naught? 0. What is the value of y naught? 4, right. In this solution, replace x by x naught, y by y naught. So, what you will get? 4 is equal to C1 into e to the power 0 plus C2 into e to the power 0, right. E to the power 0 means 1. I hope we will get C1 plus C2 is equal to 4, right. And along with that, they have given one more condition, y single prime of 0 is equal to minus 2, right. I am going to use y single prime of 0 is equal to minus 2, right. So, it means I want to find out the derivative of this function y single prime is equal to C1 is an arbitrary constant, derivative of e to the power x is e to the power x, and C2 is constant, keep as it is, e to the power minus x is minus times of e to the power minus x, right. So, you can obtain the derivative of the this equation, is it clear, right. So, in this equation I can replace x naught by 0 and y naught by minus 2, sorry, y single prime of 0 is equal to minus 2, is it clear. Now, exactly in the similar way I can obtain C1 minus C2 is equal to minus 2 from this equation, right. So, it means we have obtained two equations and two unknowns, is it clear, right. So, we know that we are able to solve these two equations, right. So, I hope one is plus, another one is minus, C2 cancels with C2. So, if you add these two equations, I can obtain C1 is equal to 1, right. So, once you get the value of one unknown, I can substitute either in the first equation or in the second equation, right. By substituting, I can obtain the value of C2, right. So, what is the value of C2? You will get equal to 3, right. So, it means using the given conditions, I have obtained arbitrary constants present in the solution, right. So, it means we will come to know that along with the differential equation, suppose if they give an initial some initial conditions, right. So, using the initial conditions or why we are going to use the initial conditions to find the value of an arbitrary constants, namely C1 and C2, right. Then I can replace C1 by its value, C2 by its value, is it clear. So, what is the value of C1? C1 is 1, right, and what is the value of C2? C2 is 3. It means we can obtain a particular solution y is equal to e to the power x plus 3 times of e to the power minus x, is it clear, right. And I can draw the graph of this equation, right. So, observe the graph, right. This is the graph of the equation, is it clear, right. And you can obtain a point. What is that point? They have given in the hypothesis of the problem 0, 4, right. You can observe the 0, 4, this is the point, and you can calculate slope of the slope at this point, right. I hope you will get minus 2, is it clear, right. So, what is the slope of the slope at that point is minus 2, is it clear, right. So, if it is possible, you can draw the same graph once again by using the software, is it clear, right. Now, as I have mentioned, right. So, this software is called GeoGebra software. So, now I want to use a new sheet. For that reason, that I will select a new, right. Then now I want to type the solution equation, right. Just now we have obtained. What is the solution equation? E to the power x plus 3 times of e to the power minus x. Here I am going to type exp, exponential, right. exp. So, within the bracket, I have to type x. So, it represents e to the power x, right. So, minus sign, so it is plus not minus. I have to type plus 3 times of, so again exponential function e x p. So, within the bracket I have to type minus x, minus times of x, right. Then I have to press enter key. So, I should not leave a space, that is why it is showing an unknown function. Okay, I will type once again e x p sorry, I am unable to show you. I have to type the same thing e x p to the power minus x. Now, if you type in this way, I hope you can obtain the same curve. Yes. Now, exactly in the similar way, I want to select one more example. Solve initial value problem y 4 times of y double prime plus 4 y single prime plus 17 y is equal to 0. Here also they have given y of 0 is equal to minus 1, y double dash of 0 is equal to 2, right. So, by the formula we find the roots of an auxiliary equation, right. So, it means you can write it in the symbolic form, right. So, y double prime can be replaced by 4 times of d square, right, plus 4 times of d plus 17, y is common, you can take out, right. Then again d can be replaced by m. I hope you can obtain this equation 4 m square plus 4 m plus 17 is equal to 0. So, it is an auxiliary equation, right, and it is a second degree polynomial, right, or it is of the type quadratic equation. Is it clear? I hope you know the formula m is equal to minus b plus or minus square root of b square minus 4 ac, right. Here a is equal to 4, b is equal to 4 and c is equal to 17 using the formula. So, I hope we can obtain 2 values, right. Here what we will get? You will get 2 complex numbers minus 1 upon 2 plus 2i and another value is minus 1 upon 2 minus 2i. So, it means these 2 are complex roots, right. So, then if the roots are complex, then what is the solution? So, we can write down solution in this form e to the power, right. So, it is actually minus x by 2 c1 cos 2x plus c2 2x, right. So, why it is minus x upon 2? Here real part is minus 1 upon 2. That is why you can write e to the power minus x by 2. Yesterday I have explained, if the roots are complex, then how we are going to write down the solution. Is it clear? Using that formula, we can write down a solution in this form, right. Friends, again here they have given initial conditions, y of 0 is equal to and y single prime of 0 is equal to. Now, I want to use the given conditions, right. So, applying the conditions y of 0 is equal to minus 1, we can obtain c1 is equal to minus 1. Is it clear? and differentiating the solution. Here we have obtained y is equal to, now I want to find out the derivative, because I want to use one more condition, y is single prime of 0. If I differentiate this function using the product rule, I will get the derivative, then I can use y is single prime of 0 is equal to 2, right. So, using that I can obtain the value of another constant, namely C2 is equal to 3 by 4, right. Then I can replace C1 and C2 by obtained values. C1 can be replaced by minus 1, C2 can be replaced by 3 by 4. I hope so. You will get y is equal to e to the power x by 2 minus times of cos 2x plus 3 by 4 times of sin 2x. Suppose if you plan to draw the graph again by using the same software, it is possible to draw the graph. I hope you may get a graph like this, right. So, friends, you can observe the previous curve and this curve, right. Here I have considered roots are real and different, roots are complex, right. And along with that, what we want to observe, right, it is given that in the hypothesis y of 0 is equal to minus 1, right. So, that point, it means according to the initial value problem, curve is passes through the point 0 comma minus 1. Yes, the curve is passes through this point. At this point, I can draw a tangent, right. If you draw the tangent, so you will get a tangent like a blue curve. At this point, we want to calculate slope, right. Slope is also given, as clear, slope is 2, right. So, you can verify whether we have obtained the correct solution or not, as clear, right. And the shape of the curve is not same in all the cases. It means depending upon the nature of the roots, right. So, you will get different curves. Then you can think, right. So, there is a specific meaning why we want to calculate real and equal roots, why we want to calculate real and different, and sometimes we are expecting complex roots, is it clear. I will give more details, right. So, suppose if you have roots real and equal, what is the meaning, or why we will get a curve in a particular manner, right. Suppose if you obtain a complex roots, why you will get a curve like this, is it clear, right. So, there is a specific meaning for this, right. So, we are going to interpret the curve shortly. Okay. I am going to consider one more similar type of example. It is given that y double prime minus 10 times of y single prime plus 25 y is equal to 0, right. So, exactly in the similar way, now we want to find out symbolic form. Symbolic form means you can replace d square y upon dx square by capital D square minus 10 d plus 25 into y is equal to 0. Then you can take a coefficient of y, replace capital D by m, you will get an auxiliary equation. What is the auxiliary equation? M square minus 10m plus 25, right. So, the same thing can be written as m minus 5 whole square, because if you expand, so what you will get? You will get the same terms, is it clear, right. It is just like x square. If it is an x square, then it can be write down in this form, is it clear, x into x. It means m minus 5, m minus 5, right. So, it means that implies m minus 5 is equal to 0 or m minus 5 is equal to 0, right. That implies m is equal to 5, m is equal to 5. It means you will get real and equal roots. That is why here I have written m1 is equal to m2 is equal to 5, right. So, all the roots are real and equal. So, in that case, how do we write down the solution? right. Solution can be written down in this form: y of x is equal to c1 e to the power 5x plus c2 into x into e to the power 5x, right. So, friends, here e to the power 5x, e to the power 5x is common, right. Instead of writing 2 times, right, if it is possible, you can write down c1 plus c2x into e to the power 5x, or we can write down in this form, right. So, when we draw the curve, right, I have drawn the solution curve again by using the same software, namely GeoGebra, right. It is very simple. Simply you want to type this command, you can give some values for C1 and C2. Is it clear, right? So, for various values of C1 and C2, curve is moving. Is it clear, right? So, you can observe this curve, right? So, this curve is different from the previous curve. It means all the 3 curves are different, right? So, these curves depends upon the nature of the auxiliary equation, right. So, we will come to know how do we get various curves, right, or why we must give and more importance about the nature of the roots, right. So, depending upon the nature of the roots, we will get the different curve, then we shall interpret about the curves, right. Okay. So far, I have solved few examples about second order homogeneous equations, right. So, friends, especially in differential equations, especially in second order differential equation, we must know this type of equations, right. So, y double prime plus k square into y is equal to 0, y double prime minus k square into y is equal to 0. You observe these two equations are second order homogeneous equations. How do you say that homogeneous equations? Because a right hand side term is 0, right. So, that is why I will call it as an second order first degree homogeneous equation, right. So, these two equations plays an important role in applied mathematics. That is why especially while studying differential equation, we must know these two equations, right. And these two equations are like our previous examples. Is it clear, right. Now, as usual, you can write down in symbolic form, right. So, d square y double prime can be replaced by capital D square plus k square into y is equal to 0, or similarly this equation can be written as a d square minus k square into y is equal to 0. Is it clear, right. So, we will get an symbolic form. Once we get an symbolic form, capital D can be replaced by m. You will get an auxiliary equation, m square plus k square is equal to 0. This implies m square is equal to minus times of k square. Therefore, m or m1 is equal to ki, m2 is equal to minus ki. It means from this equation we can obtain 2 roots, right. So, what is the nature of the roots? Here roots are complex. Is it clear? Real part is 0, imaginary part is k into I, right. So, therefore, solution of this equation is of this form: C1 into cos kx plus C2 into sin kx. Is it clear, right. So, because real part is 0, that is why I have not written e to the power alpha into x. Is it clear what I have shown yesterday? If you want to, you can write down e to the power 0 into x into the bracket, you can write down these two terms, right. And similarly, here one more differential equation is there: y double prime minus k square into y is equal to 0. Exactly in the similar way, you can write down in symbolic form: d square minus k square into y is equal to 0. Again, d can be replaced by m. It becomes an auxiliary equation: m square minus k square is equal to 0. Therefore, m square is equal to k square. Therefore, m is equal to, or m1 is equal to k, m2 is equal to minus k, right. So, you will get 2 roots, real and different. Then you can write down the solution: C1 e to the power right. So, k into x, C2 into e to the power minus k into x, right. And you can find out, or you can take C1 is equal to C2 is equal to 1 by 2, right. So, as I have mentioned in the earlier example, I have shown one graph. C can be, C means arbitrary constant, can be any value, right. In one example I said that you can take arbitrary constant is equal to minus phi to plus phi u, is it clear, or you can take any value. Suppose if I take C1 is equal to C2 is equal to 1 by 2, we get the particular solution, right. So, it means in this solution I am going to replace, right, C1 by 1 by 2, C2 by 1 by 2. So, what we will get, y of x is equal to 1 by 2 e to the power kx plus e to the power minus kx, is it clear. And this symbol can be written down in cos hyperbolic k into x, right. So, you know the definition of a hyperbolic function, is it clear, right. So, using the hyperbolic function, so we can replace this by hyperbolic function, right. So, you may ask why we want to take C1 and C2 is equal to 1 by 2 only, not necessarily, right. You can take C1 is equal to 1 upon 2, C2 is equal to minus 1 upon 2. Suppose if I take these two values, right, then I can replace C1 by 1 upon 2, C2 by minus 1 upon 2. I hope solution is in this form, 1 by 2 times of e to the power kx minus e to the power minus kx, right. So, again when we observe this function, we will come to know that, so this is the definition of a sine hyperbolic function, as clear. That is why this can be written down in the form of a hyperbolic function, sine hyperbolic kx, right. Or the alternative solution is C1 into cos hyperbolic kx, C2 into sine hyperbolic kx, right. So, if we willing to draw the curve of this equation, it is possible to draw the curve again by using the same software, right. C1 into cos hyperbolic kx, here you want to define C1 and C2, or you can take C1 is equal to 1 to 5, k is equal to any number, then you will get the corresponding graph, right. Friends, so far I have solved some second order linear differential equation with constant coefficients, and I have also solved one or two initial value problems. It means now we are familiar with differential equations. How do we calculate a solution of a second order linear differential equations, especially in homogeneous equations, is it clear. It means we are familiar with the mathematical part, right. So, then as I have mentioned, you will get different curves, how we are going to interpret those curves, or how we are going to use differential equations in engineering disciplines. So, now we want to concentrate on application part. Application part means just now I told that one or two equations worth to know second order differential equation, right. So, you may ask why we want to know such type of equations, or how we are going to interpret such type of differential equations in engineering disciplines. That is why we can say that many of the laws of nature, right. So, differential equations are the language of nature. Many people will say that differential equations are the language of nature. In other words, in engineering, in physics, in chemistry, in biology, and in astronomy. It means friends, you can take any subject, right. So, differential equations plays an important role. Find their most natural expression in the language of a differential equation. So, that is why many people will say that differential equations God gift for us, right. Then you may ask why, or how do we say, or how do we make such type of statements, right. Friends, differential equations are also like human beings or human system. Say for example, my body is one system, right. I will behave according to the temperature, suppose if you consider one parameter, if it is cool, then my behavior will change. If it is too hot, my behavior will change, right. So, exactly in the similar way, if you consider any differential equation, right, differential equations will also behave like a human being systems, right. So, differential equations vary point to point. That is why many people will say that differential equations are God gift for us, right. For example, Newton's law of universal gravitation or Maxwell's field equations, the motions of planets and the refraction of light are important examples which we can be expressed using differential equations, right. Note that much of our understanding of nature comes from our ability to solve a differential equation, right. If I want to know more thing about the nature, then I must be able to solve more and more differential equations, right. I can give one simple example. Suppose if I want to work on weather prediction, right. If I want to predict after 1 week what happens in a particular place, then I must be able to solve a differential equation. So, that is the meaning of this note. Okay. So, you can say that why differential equations arise so readily in the science. It is very simple. If y is equal to f of x is a given function, the derivative of this function is denoted by df of dx, can be interpreted as the rate of change of f with respect to x. So, they have given a function, right. So, we want to find out derivative of the given function, we can find out the derivative of the given function, right. So, what is the meaning of the derivative of the function? We are already familiar with the rate of change of f with respect to x, right. So, we can elaborate in the following way. In any process of nature, the variables involved are related to their rates of change by the scientific principles that govern the process by the law of nature, right. When this relationship is expressed in mathematical notation, the result is usually a differential equation, right. So, that is why we can say that differential equations arise so readily in the science, right. Friends, dy by dx means it is containing two variables, right. So, one is a dependent variable, another one is a independent variable, right. Suppose if you want to establish the relation between those two variables, if you want to study a relation between two variables, then we want to use a differential equation, right. Now, as I have mentioned, the differential equations can be used, can be interpreted in engineering disciplines, right. So, so far we have discussed some mathematical part of the differential equation, is it clear? And I have given a little bit interpretation of the differential equation, right. Still we have not discussed in depth of the differential equation. Friends, in the next session I am going to discuss in depth of the differential equation. I am going to consider only second order differential equation, right, and I am going to consider any one of the physical system, how we are going to represent particular differential equation in case of a mechanical system or in case of any electrical system, right. So, we shall discuss all those things in the next session. So, thank you very much.